Hello children, so welcome to aimsindia's online classes. Today from mathematics subject, quadrilaterals topic we are going to discuss. So here children, so if A, B, C and D are coplanar points, means this A, B, C, D should lie in the same plane, on the same surface they have to lie. Then they are said to be coplanar points. So if A, B, C, D are coplanar points such that first condition, no three of them are collinear, means no three of them should lie in the same line. That is first condition. Second condition, the line segments AB, BC, CD, DA, because with the help of 4 points we can form 4 line segments. They are AB, BC, CD, DA. They do not intersect. They do not intersect except at their endpoints. That is second condition. If these two conditions are satisfied, then the figure made up of the 4 line segments is called the quadrilateral. Quadrilateral. So taken from the word quad or quadra, which means 4. The points which we have taken, that A, B, C, D are called vertices. Means we have A, B, C, D 4 points which are coplanar, lying in the same plane, and no 3 of them, you can check any 3, 1, 2, 3, they are not lying on the same line, so they are not collinear. In the same way, D, C, B not collinear, C, B, A not collinear. So any 3 points of them are not collinear. Any 3 points of them are not collinear, or no 3 of them are non-collinear, and the segments AB, BC, CD and this one DA, they do not intersect except at their endpoints. They do not intersect except at their endpoints. You can observe this AB line, BC line, they are intersecting at B point, which is a endpoint of AB and also an endpoint of CB. And this ADBC, this AD, D is the endpoint of AD and also the endpoint of CD. So they are intersecting or they are meeting exactly at their endpoints. So if all these conditions are satisfied, then this quadrilateral, the figure formed by these 4 points satisfying all these conditions is called a quadrilateral. And this A, B, C, D are called vertices of the quadrilateral. So a quadrilateral is named by listing its vertices. So starting at any vertex and reading clockwise or counterclockwise. So we can start from any vertex. If you start from A, B, C, D, in clockwise direction, we can name it as ABCD. Or if you start from A in anti-clockwise direction, we can name it as ADCB, like this. Or there is no compulsion that we have to start from A. We can start from B, then BCDA or BADC. So we can name from any vertex, we can name in any direction, either clockwise or anti-clockwise. But we have to name it with the help of vertices. So this is about a quadrilateral, children. Next, children. Next, sides, angles and diagonals of a quadrilateral. Sides, angles and diagonals of a quadrilateral. So the four line segments AB, BC, CD and DA are called its sides. This AB, BC, CD, DA are called sides of the quadrilateral, and the four angles, angle DAB, angle ABC, angle BCD, angle CDA are called its angles. So here at point A, because of this ray and because of this ray, at common endpoint A, one angle is formed, which is named as DAB, angle DAB, and this one angle ABC, this one angle BCD, this one angle CDA. Like that, four angles. Quadrilateral will be consisting of four angles. Along with four sides, it will be consisting four angles. And this AB side and BC side are called consecutive sides. They are side by side. They are side by side. But AB and CD, but AB and CD, but AB and CD are called non-consecutive sides because they are not side by side. They are not side by side. Or this A, B are called consecutive vertices. This A and C are called non-consecutive vertices because they are not side by side, or they are also called opposite vertices. So the line joining the non-consecutive vertices or opposite vertices, this AC and BD, these two line segments are called diagonals. These two line segments are called diagonals. So the symbol for quadrilateral is this quad ABCD, means quadrilateral ABCD. For this quadrilateral ABCD, AC and BD are the two diagonals. AC and BD are the two diagonals. So quadrilateral consists of four sides, four angles, two diagonals, four vertices. Four vertices. Four vertices. Okay, children? Four vertices. Like that, it will be having common elements. One minute, children. Next. Adjacent sides and opposite sides. Adjacent sides and opposite sides. So two sides of a quadrilateral are said to be adjacent. Two sides of a quadrilateral are said to be adjacent sides of the quadrilateral if they have common endpoint. What is the main point, children? They should have common endpoint. This AB and BC are called adjacent sides because they are having endpoint B as common endpoint. For AB also B is a endpoint. For BC also B is a endpoint. So they are called adjacent sides. So whereas two sides of quadrilateral are said to be opposite sides if they are not adjacent or if they don't have common endpoint. If we compare AB and CD, these two sides, they don't have any common endpoint because the endpoints are AB here, the endpoints are CD here. So they don't have any common endpoint. So they are not adjacent. So they are opposite. So which are not adjacent, they are said to be opposite sides. So in the quadrilateral, this AB and AD are adjacent sides, but AB and CD are opposite sides. So AB and AD are called pair of adjacent sides. Pair of adjacent sides. In the same way, AB-BC, pair of adjacent sides. BC-CD, pair of adjacent sides. CD-DA, pair of adjacent sides. So in the same way, ABCD, pair of opposite sides, BCAD, pair of opposite sides. So, okay, like that. Like that. In the quadrilateral, we will be having adjacent sides, opposite sides based on the common endpoint. If they have common endpoint, they are called adjacent sides. If they don't have common endpoint, they are called opposite sides. Next one. In the same way, we have adjacent angles and opposite angles. So, if this is the quadrilateral, A, B, C, D, then we will be having adjacent angles and opposite angles for a quadrilateral. Adjacent angles, opposite angles for a quadrilateral. So here, children, two angles of a quadrilateral are said to be adjacent angles of the quadrilateral if they have a side of the quadrilateral in common. What does it mean, children? Suppose AB, suppose this is AB is one ray, AD is one ray, and this is the angle DAB, this angle, and we have one more angle here, which is DAB angle formed because of AB ray and AD ray, and AD ray. In the same way, we have this angle CBA, which is formed because of CB ray and BA ray, or AB ray, BC ray, which is formed because of AB ray, BC ray. If you compare the sides of the angle because of which angle is formed, in these sides, one side is common. One side is this AB side is common for in both the angles. So if they have a side, of quadrilateral in common, so then they are called adjacent angles. Now these two angles, they are having AB side as common, so they are called adjacent angles. Whereas if you take this AB, if you take this angle B, CBA angle, and if you take this angle, so this angle is formed because of CD and AD. This angle is formed because of AB and BC. So these two angles, they don't have any side common. So they are not adjacent angles. They are called opposite angles. So in this diagram, angle A, angle B, pair of adjacent angles, or angle B, angle C, pair of adjacent angles, or angle C, angle D, pair of adjacent angles, or this angle B, angle C, pair of opposite angles, angle C, angle A, pair of opposite angles. Like that we can have adjacent angles and opposite angles. Okay, children. Next, angle sum property of a quadrilateral. So let's draw any quadrilateral ABCD. You can also try this, children. Draw any quadrilateral ABCD on a paper with the help of 4 points, and scale, and you try to measure its angles with the help of compass or protractor or divider, anything, any geometrical object. Try to measure its angles. And write the results. ABC, how much? ABC, this B angle, how much we have measured? BCD, how much you have measured? CDA, DAB, how much you have measured? That 4 angles you measure, children, and try to do their sum. Try to calculate their sum. You can found that their sum will be 360 degrees. You can draw different types of quadrilaterals. Try with different types of quadrilaterals. Any quadrilateral you can draw. ABCD values may change, but sum of ABCD will always be equal to 360 degrees. That will never change. So the sum of angles in a quadrilateral is always 360 degrees. Is always 360 degrees. Next one, you find it is 360 degrees. You can draw more quadrilateral like PQRS, like LMNP. You can measure any type of quadrilateral. If you measure this 1, 2, 3, 4 or measure this A, B, C, D, what you will find? Total 1, 2, 3, 4 sum will be 360. A, B, C, D sum will be 360. Hence we can conclude that the sum of angles in any quadrilateral is equal to 360 degrees. 360 degrees. Next children, proof children. So without measuring, you could have found the sum as under. Means how we can prove the sum of angles in a quadrilateral is 360 degrees means without measuring means for that we have a proof children. Draw one diagonal, say BD. Let's draw a diagonal. Diagonal means what is diagonal? Line joining opposite vertices is called diagonal. Draw one diagonal BD. This diagonal will divide quadrilateral into two parts. This is first part, this is second part. So sum of angles in triangle. Sum of angles in triangles equal to 180 degrees, or we can call it as two right angles, which is equal to 180 degrees. Sum of angles in two triangles means two right angles plus two right angles, four right angles. So 2 into 180, 360 degrees. So angles of a quadrilateral with the help of triangle, we can tell that it is equal to 360 degrees. Next one. So interior and exterior angles of a quadrilateral. Interior and exterior angles of a quadrilateral. So in this figure, we have angles marked 1, 2, 3, 4. This 1, 2, 3, 4. We have 1, 2, 3, 4, which are present in the interior part of the quadrilateral. So they are called interior angles. Interior angles, or we can call them as angles of the quadrilateral ABCD. Angles of the quadrilateral ABCD. ABCD. Suppose if we extend AB, here outside one angle will be formed, which is present in the exterior part of the quadrilateral, outside of the quadrilateral. If we extend BC, one more exterior. If we extend CD, one more exterior angle is formed here. If we extend DA, one more exterior angle is formed here. But this 1 and X, lying on the same line, because this is the line, this is the ray. So same side of the line, angle sum will be 180 degrees. 1 and X will form a linear pair. 1 plus X 180 degrees we can tell. 2 plus Y 180 degrees. 3 plus Z 180 degrees. 4 plus T 180 degrees. Like that we can tell. Now, this exterior angles sum property. Exterior angles sum property. Exterior angles means in the figure we have got X, Y, Z, T. We have got 4 exterior angles. Why we have got exterior angles? When we extend 4 sides of the quadrilateral, we will get 4 exterior angles. Now we are going to find the sum of the 4 exterior angles. Here children, if the sides of quadrilateral are produced in an order, the sum of the four exterior angles so formed is 360 degrees. Not only inner part, the inner sum of inner angles of quadrilateral 360, outer exterior angles also, their sum is 360 degrees. So for that proof is, so let's ABCD be a quadrilateral whose sides are produced in order to form XYZT. Angle 1, 2, 3, 4 are interior angles. 1, 2, 3, 4 are interior angles. This 1, 2, 3, 4 interior angles. This XYZT exterior angles. 1 and X form a linear pair. 2 and Y, Z and 3, T and 4 all form a linear pair. So 1 plus X 180, Y plus 2 180, Z plus 3 180, T plus 4 180. Adding all the angles, what we get, children? X plus 1 plus Y plus 2 plus Z plus 3 plus T plus 4. T plus 4 equal to 180, 180, 180, 180, which is equal to 720. Or X plus Y plus Z plus T, we can separate them. 1 plus 2 plus 3 plus 4, we can separate in one group. So X plus Y plus Z plus T equals to this 1 plus 2 plus 3 plus 4, they are interior angles. So the sum of interior angles in a quadrilateral is 360 degrees. So we can substitute 360 here. So X plus Y plus Z plus T equal to 720 plus 360 that side minus 360, or which is equal to 360. So X plus Y plus Z plus T equal to 360. What are X, Y, Z, T? Exterior angles. So sum of exterior angles of a quadrilateral equal to 360 degrees. Hence it is proved. Next one. Now we have some example problems. So find the value of the unknown angle in each of the following figures. Each of the following figures. We have to find unknown angles. So 70, 80, 130, X. So 70, 80, 130, X. What is the angle sum property of quadrilateral? Angle sum is interior angle sum. How much? All four angles sum equal to 360 degrees. So X plus 130 plus 80 plus 70 equal to 360. So 130 plus 70, 200 plus 80, 280. X plus 280, 360. X equal to 360 minus 280. X equal to 80 degrees. Second diagram. 90 plus 150 plus 2W plus W equal to 360. So 90 plus 150, 240. 2W plus W, 3W equal to 360. 240 comes this side. Minus 240. 3W equal to 360 minus 240. 3W equals to 120. W equals to 120 by 3. 120 by 3. W equals to 120 by 3, which is equal to 40 degrees. Which is equal to 40 degrees. So this one. 72, 25, N 30. These also 1, 2, 3, 4. Formed by 4 sides. It's also a quadrilateral. So 72, 30, N 25, 360. 72 plus 30, 102 plus 25. 127 plus N 360. N equal to 360 minus 127, 233. In this way, we can find the missing angles of a quadrilateral. Next one. Next one. Two angles of a quadrilateral are of measure 50 degrees. Two angles are of measure of 50 degrees. And the other two angles are equal. What is the measure of each of these angles? So let the equal angles be x degrees. Other two angles are 50 degrees each. So but angle sum property, sum of all angles 360. Two angles are x and x. Two angles are 50, 50. So x and x, how much? 2x. 50 plus 50, 100. 2x plus 100 equal to 360. 100 goes aside. 2x equal to 360 minus 100. 2x equal to 260. So x equal to 260 by 2, 130. So each of equal angles 130. each of equal angles 130. If this is a x, if this is x, x, if this is a 50-50, then this equal angles, each one, this is 130, this is 130. Next one. The angles of a quadrilateral are in the ratio 2:3:5:8. Find the measure of each of the four angles. The sum of all angles is 360. Let the angles be 2x, 3x, 5x, 8x. Then 2x plus 3x plus 5x plus 8x, 360 degrees. 18x, if we add all, 18x equal to 360. X equal to 360 by 18. So which is equal to 20. So 2x will be 2 into 20, 40. 3 into 20, 60. 5 into 20, 100. 8 into 20, 160. So these are the angles. But, okay. So they asked us to find angles. So we have got the angles. We have got the angles. But for finding this, one more method is there. So total sum of all angles 360 degrees we know. The angles are in the ratio 2:3:5:8. What is sum of ratios? 2 plus 3, 5, 5 plus 5, 10, 10 plus 8, 18. All total 18 parts we have. So then what is first one? 2 parts out of 18 parts in 360 degrees. 18 20s are 22s are 40. Like this also we can find. Second one, 3 by 18 into 360. 5 by 18 into 360. 8 by 18 into 360. Like that we can find. Next one. So in the adjoining figure, the bisectors of angle A and angle B meet at point P. The bisectors of means this is a ABCD is the quadrilateral. This is angle A. This is angle B. We are having a bisector of angle A. Bisector of angle A, which divides it into two smaller parts, equal parts. Bisector of angle B. Bisector of angle B divides them into smaller parts, equal parts. Both the bisectors meet at P. Both the bisectors meet at P. C value 96, D value 30. So what is the measure of APB? What is the measure of APB? So we know that ABCD 360 degrees. ABCD total angles 360. So A value we don't know, B value we don't know, C value 96, D value 30 degrees equal to 360. 96 plus 30, 126. A plus B plus 126, 360. So then A plus B equal to 126 will come this side. 360 minus 126, 234. But A plus B value 234. So then what about half of A, half of B, half of 234? If you take half of A, half of B, it will become half of 234, which is equal to 117 degrees. So next, this is 117 degrees. Sorry. Half of A, half of B. This is half A. Only this part is half B. Now half A plus half B plus P. 180 degrees. Half A means PAB, PBA, APB. These three. In triangle PAB, small triangle, these three sum equal to 180 degrees. But APB equal to half A. APB equal to half A. And PBA equal to half B. So in this three, so these two, this is half A, this is half B. Half A plus half B, how much? 117 degrees. So APB plus 117 degrees we can write. So APB equal to 117 this side minus 117. So 180 minus 117, 63 degrees. Okay, children. So that is about today's concept, children. About quadrilateral we have learnt. Sides, angles, diagonals. adjacent sides, opposite sides, adjacent angles, opposite angles, angle sum property, interior angles, exterior angle sum property, and some example problems we have solved. So thank you for watching our video, children. So please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, www.aimstoday.in for previous classes, quizzes, worksheets, activities, English classes, coding classes. Thank you, children. Have a good day.